Hey guys, welcome back. Well, I finally managed to do it. I've been saying all along, well, I'm going to try out Nina. I'm going to switch to Nina. Love the autofocus. I'm going to, okay, here it is. I'm going to switch to Nina. Well, I finally did it. Now that I've moved away from my very temperamental SCT and have installed the William Optics GT81 on the mount, I'm ready to also give Nina a try, and so I wanted to share with you some of my observations and findings from the past couple of nights of imaging with this pair, using Nina as the driver for the imaging session. Let's just go over some of the settings that I'm using in Nina. A few things in setting the file name, what I've included here, and I may change this, but right now I'm including the star count, and then the target name, the filter, and then exposure time with a little S afterwards, so it says 300 seconds, for example. And then a G, and then the gain number, so it's G139. And then a sensor temperature, C, for Celsius. So I'm including, and then of course the date and time. So that's my file naming convention. I may switch star count to the half flux radius later on. Let me try that out just to see if I like that better. But it is handy seeing some metric that relates to the goodness of the picture in the file name itself. Over on the other settings here, I am using the side of peer. That is an option with the Celestron mounts that does provide side of peer notification to ASCOM. I'm not using recenter after flip. I didn't do a meridian flip, at least not in the conventional way. I'll show you what I did here in a second. I did play around with the auto stretch factor as the images came in. I played around with this number a little bit to provide a little bit better auto stretch, and I may have to change that. It may be an image to image kind of thing. I don't know. When the sequence ends, I do park the mount and I start warming the cameras. Over here in the weather station option, there are several. You could use the weather map org or whatever that is, and I do have a key for that. However, I do also have a Pegasus Astro Ultimate Power Box, and instead of using it as an ASCOM switch, which is possible, you could connect to the Pegasus Astro to the Ultimate Power Box via the ASCOM switcher. I don't do that because I prefer to keep the interface of the Power Box. I like the interface, and it gives me the option of switching over, looking at the graphs, and then at the end of the night going over to settings here and saving these graphs along with the power graphs off to a set of files in a given directory, so which is very useful for diagnosing some problem that may have come up. But anyway, I like the interface with the Ultimate Power Box, so instead I just start up the Ultimate Power Box at the beginning of the night, start up the Celestron Next Remote here, and then go into Nina to bring in the connect to the mount and then connect to the Ultimate Power Box for these values of temperature, humidity, and dew point, which are just coming from the environmental sensor here on the Ultimate Power Box. On the camera side, everything worked well. I'm connecting to my ASI 1600. I cooled down to a minus 10 degrees. I did find that the cooling rate is much faster than what I currently have set in APT. In APT, I've got it cooling down in steps, so it's a fairly long process, probably longer than it needs to be. This one seemed to be rather quick, so I might actually change the minimum duration here to make it last a little longer so it's not cooling down too fast. I don't know what too fast is. I don't know if the cooler is capable of going too fast, but I may do it just to ease my mind a little bit. And then there's a couple of other camera settings here, the default gain, default offset, and the low USB limit to keep USB traffic down to a relative minimum. This is where I did have a little bit of an issue. As it was at that night, I had a ZWO filter wheel 1 and a ZWO filter wheel 2, and I selected 1, and then I took pictures all night thinking I was taking HA data, when in fact I probably got O3 data instead. Anyway, to resolve this, I called up the Profile Explorer, which is one of the utilities that comes with the ASCOM installation, scrolled down to the filter wheel drivers, and at the time there were 2 listed in here, so I deleted one of those and left me with filter wheel, what is 2, but now I've renamed it to just ZWO filter wheel, and hopefully that will avoid the problem that I had that last night that I was out. On the options equipment panel here, there are a number of things here to talk about. One of the things is the focal length of the telescope. It's a The GT81 is 478 millimeters nominally. However, with the field flattener and focal reducer, that drops that number down to 385 millimeters based on some plate solving results and estimating the actual field of view from those plate solving results. So I've done that. In the previous video, you'll see how I came up with an autofocus step size of around 40 to 50. I'm taking 5 steps off of the nominal focus to step out and then step through, so it does about 11 steps roughly speaking. I'm using the half flux radius and the hyperbolic curve fit method. I disable guiding because when the focuser operates, it introduces a torque to the mount, which does disturb the pointing of the mount, and if the guiding is on, it tries to correct it back, and it just takes longer for it to settle down. So I do turn off the guiding. I'm probably going to add in maybe a additional 2 second delay just to settle things down a little bit. As I say, that torque from the focuser does kind of cause a bit of a jiggle in the motion. For backslash compensation, I'm using the overshoot method, and I've got the number set to 120. So when the autofocus routine moves the focuser out, it goes the distance out plus 120 steps and then back in 120 steps, so that it eliminates all the backlash, and you're always in contact. The gears are always in contact for moving in. Now that backlash number, this doesn't have to be an accurate number, it just has to be larger than your backlash, and in the previous video I measured the backlash of this Pegasus Astro Focus Cube 2 combined with the GT81 as about 70 steps, so I'm going well beyond the 70 just to make sure that I use up the backlash. Now over here in the filter wheel, this is where I've got to do some more work here. I'd like to be able to check the luminance filter and tell it to use this for autofocusing from that point forward, but in order to do that, you've got to have reliable focus offsets, and I'll show you some of the oddities that I've been experiencing trying to nail down what the focus offsets are. We'll talk about that in a second, but that's my objective for now. And what I have been doing, what I will be doing probably for the next day or so, is unchecking this so it does not use the luminance filter for every autofocus routine. It just uses whatever filter happens to be set, and I won't have any offsets. I've turned those to 0, but it will use these autofocus exposure times that I have set for the different types of filters. So that's one of the things that I'm still trying to nail down. This is a stellarium picture. I've got it frozen here at 10:30 p.m., which is a critical junction in the night and making a switch. I've got this cyan line here represents the which you can see of my horizon. Obviously I've got the meridian more or less drawn in here. The first thing I'm doing, starting at about 8:30, so 2 hours before this time that you're seeing here, I slew over to M31, and that because the moon is out and basically full on right now, I'm just taking some HA data for now on M31, and after about an hour, a little more than an hour, I have it slew over to M33 and again pick up another hour or so of HA data on M33. Once the moon goes down, then I'll switch over to the broadband filters, but for now I'm just going to steal some HA data off of these galaxies. I want to put the GT81 through its paces on both some galaxy targets, some broadband targets, and some nebula targets. So that's just why I'm going to these galaxies right off the bat here. And speaking of bat, the next target is the Flying Bat Nebula of SH2-129. But I've got to be careful here. After a couple of hours imaging over here, if I commanded the mount to go to the telescope, to go to SH229, I've got settings in the CGEM, the Celestron CGEM mount that I'm using, that one, allow a bit of RA error plus or minus the meridian, because I've got relatively short telescopes. I don't really have a very high risk of the scope or the mount bending over backwards over the meridian and having the camera hit a leg of the tripod, for example. So I do have a fairly permissive RA limits around the meridian. The second setting I have is when making a move, making a go-to move, it's commanded to favor the current side of pier. So right now it's on the eastern side, and if I commanded it to go from M33 directly to SH2-129, it would probably just lean over backwards and capture SH2-129 by looking back over its shoulder, so to speak, which is not what I want. I want to follow SH2-129 all the way down to the horizon. So that's not what I do. Instead, I program in a detour over to Vega, a target, any target, that's on the known to be on the far west side. And then after it gets to Vega, then it'll come back to SH2-129, knowing full well that it's going to favor this side of the pier, and it will have done essentially a manual meridian flip to get to this target. Let's go over to Nina and look at this imaging sequence that we have set up here. You see I have M31, M33, Vega, and SH2-129. In M31, I have it set to slew to the target, then center on the target, and then start guiding. And then I have the autofocus options are set up to do an autofocus run once it gets there, and do an autofocus every 40 minutes. So it'll go about through half of the imaging time that I have allocated of about a little over an hour, do about a half of the imaging time, and then do a refocus and finish up the remainder of the images that I have identified for this particular target. Before then it slews to the next target. And the imaging side, we have the HA data is the only thing that's enabled right now. I've got some placeholders for the broadband filters, but they're all turned off because we're in a bright moon period here. So I have that enabled, HA enabled, just taking 14 images. That comes to a duration of about an hour and 12 minutes or so, plus some additional time required to do the autofocus commanded here. And then once it finishes doing that, it will presumably slew over to M33. It will center on the target, and it will start guiding, restart guiding. And the same options are set up in the autofocus routine, where it'll do another autofocus once it gets there, and it'll do another autofocus midway through its hour and 12 period of time imaging M33 with the HA filter. That'll take up about 2 hours or so. That way SH2-129 is safely on the other side of the meridian. I program a visit to Vega. I don't want to start guiding. I don't want to center on the target. I just want to go there. And then when I get there, I want to tell it to just take one picture, 2 seconds with a luminance filter. Doesn't really matter. I'm not using this. It's just kind of a postcard, if you will. I'm not going to do any autofocusing options here. It's just go there. And the only reason I have it take a picture is I don't want Nina to try to outsmart me by saying, well, that idiot, he created a sequence and he doesn't have us do anything when we get there, so let's just skip this target and go to this one. I don't know if it's programmed that way. It probably isn't, but I don't want to take a chance. So I just have it take a 2-second picture to give it something to do when it gets there. That way it won't just bypass this particular target and jump right to SH2-129. And then after that 1-2-second picture, we're on the west side of the meridian. We can go over to SH2-129 and again slew the target. We will center on the target using plate solving, and we'll start guiding again. And this time I'm going to bring in, I've got the narrowband filters identified here of HA, S2, and O3, and I'm going to start picking up some S2 data tonight. And so I've only enabled that particular element of the imaging sequence here, and I've turned the others off. That gives me about 6 hours of imaging, and I've got a autofocus set to begin once the sequence starts, and it'll do it every hour afterwards until it's done. And so that's the imaging sequence, target imaging sequence that I have set up within Nina. So that's the imaging sequence to implement this little tour here within Nina. All right, so this is an HA image. You may not be able to, but I can barely make out the curved flying bat nebula here. Supposedly there's the squid-like nebula in the center of this that seems to be mostly oxygen. I hope to capture some of that sometime. But anyway, this is one of the subs that I have, and I wanted just to zoom in because in the last video we were also setting the focal reducer field flattener distance. It's a adjustable field flattener, and as you can see, the stars here are fairly round in the lower left hand corner. They are pretty round in the lower right hand corner, and this is a calibrated image, so the effect of the shadow zone of the off-axis guider has been taken out. We have a little bit of stretch going on here. I suppose that's more of an issue of tilt rather than it is of field flattening. And then in the upper left-hand corner, I think we're in pretty good shape with the stars here as well. Once I got finished with the imaging session, both before I started and after I finished, I wanted to do some autofocus runs just for each filter, trying to nail down what the focuser offsets are for each filter. I had some weird results, but as you can see, this image here shows you that the autofocus routine is doing a very good job. It's got very clean data. It does a curve fit, the hyperbolic curve fit, identifies the ideal focuser position. So that's doing a nice job. I'm very pleased with the autofocus routine. That's the main reason for switching to Nina, after all, is that it does autofocus for you. But here are some results I got. Now this is from that night's imaging. I did a series of autofocus runs for each filter around just before I started the imaging run, and as you can see, there's different values, different optimum focus points for each filter. And if you take the focusing position for each filter and subtract the luminance filter focusing position from it, these would be the offsets that you would use. And it's sort of these are reasonable numbers within the range of operation of the focuser. A roughly 10 steps is a fine focus step, so it's this 9 here, 20. These are fairly small displacements, and that's reasonable. I am a little surprised by these numbers over here being. I kind of expected the O3 data, which is kind of a blue light, to line up with a positive offset corresponding with the blue filter, and that didn't happen here, and I'll show you why I expected that in a moment. Then after the morning into the imaging ended around 5:15, I went through and repeated this process again, and of course the temperature has changed outside, so the focus positions are not going to be the same. Now over here at 5:15, I refocused, and these are my focuser offsets. Again, for the broadband filters, I would say these results are very good. They're very consistent. -9 and -6, there's no real difference. -20, -15, 25, 31. Those numbers are fairly consistent. The odd thing is that these numbers over here for the narrowband filters are quite a bit different from what I got here. Now, these numbers here are calculated based on this focuser position, the luminance filter position up here. I also, because it takes a period of time to go through all these focusers, these filters, I did it again. I focused on luminance again at the end, and then the focuser offsets based on this luminance using these values and this focus position for the luminance filter. I get these numbers. Again, there's not that much difference between these two. Quite a bit different from what we're seeing in here, and I don't have a good explanation for that. I did my usual thing that I've done with my ED102. This is the results I got by using the Bahtinov mask and the black, the opaque, the normal Bahtinov mask with the ED102, and I got extremely consistent results. In other words, the red filter, H2 or H alpha and S2 filters all grouped together as in the red light zone here. Then I had the luminance filter, then the green filter, and then the blue and the O3 filter grouped together over here. And then the distance where each of these lines crosses the zero error focus error line, that's the focus offset. And the focus offsets I got for the ED102 using this technique and that particular Bahtinov mask, I got some fairly consistent results. Again, they're in the teens and 30s, which is consistent with what I'm seeing over here with the autofocus routine, but it's way the heck off from what I'm seeing over here when I use the acrylic Bahtinov mask with the William Optics GT81. That acrylic Bahtinov mask is allowing quite a bit of light to bleed through, which is creating some confusion and some error in tools like the Bahtinov grabber for identifying the spikes. It leaves quite a bit of room for interpretation as it tries to nail down where the spikes are, and it's based on those identification of those spikes that leads to the errors. So you're getting quite a bit of fuzzy results out of the acrylic Bahtinov mask. Another thing that I'm wondering about, I don't know the answer to, but I'm wondering if the temperature dependence of the index of refraction of glass invalidates this notion of having a constant focuser offsets. I'm wondering if the focuser offsets we get on a warm night are different from the offsets we would get on a cool night, and if so, then you really can't rely on focus offset values. One takeaway that I got from this study and working with the GT81 is I don't really trust the focus with William Optics acrylic Bahtinov mask. I think it leaves a great deal of interpretation with all the light bleeding through the clear Bahtinov mask. It doesn't provide really the kind of crisp diffraction spikes that you really need for these numerical algorithms like in Bahtinov Grabber to go through and identify the spikes. I've been talking about going to Nina for a long time now. In the process of that, I've been through Nina interface, the various pages of data entry. I've actually connected to equipment and tested as much as I could during the day. Obviously, there are certain things you can't do. You can't do the slew to target, plate solve, re-slew. You can't do that without having everything hooked up at night. But for the most part, I've been through all the interface, and at least I've gotten familiar with the code, and I think that eliminated a great deal of frustration that I might have encountered if I had tried to just dive in the dead of night with Nina for the first time. The slew, then plate solve, then recenter process worked well. The autofocus went without a hitch, which is the main reason for using Nina in the first place for me. And I think it was also very valuable to define what the step size should be and what the backlash is before the first operational use. So that time also was well spent in the previous video of just figuring out how the focuser behaved in terms of minimum step size, autofocus step size, and backlash. And I think these are some of the best focused images that I've ever taken. So I am pleased beyond pleased. I did have some guiding issues, and some of it I think there's some mount gear contributions here that I'm trying to sort out. I've got possibly it's exacerbated by some mass imbalance, and I need to investigate that further. Very inconsistent filter offset results, as I showed you. The William Optics acrylic Bahtinov mask is prettier than it is useful because the diffraction spikes aren't that sharp. It leads to a lot of variability in the focus errors. As I extend this thought, I think the same could be said for William Optics temperature gauge and the focus knob gadget. All in all, I think I had a very successful first night out with the Nina GT81 pair, and I'm prepared to rack them up and try it again tonight. So let's take a look at Nina parking them out for the night. Okay guys, clear skies. See you next time.